Hey, what's up everybody? It's Mike from Cornfield Customs, and on today's episode, we're going to talk about reciprocating machines and how they work and enough information to get you guys dangerous with using one. So thanks for joining us in this episode. And like I said, we're going to be talking about reciprocating style machines. So that is just what it's called. You've probably heard of Pullmax, Lennox, Baker, Trumpf. Those are all manufacturers of reciprocating style machines. So compared to a power hammer, which we will do videos on in the future, a power hammer is going to be spring loaded and it's going to let the upper ram come up, get preloaded by springs, and it throws it really hard. A reciprocating hammer or a reciprocating machine is usually a fixed stroke. So it can have a single stroke or a dual stroke. So it only goes up and down off of a mechanical connection. There is no spring, there's no preloading. It is up and down, and you can adjust the stroke length. So like I said, this is a Lennox machine. Lennox is the manufacturer of the reciprocating machine. It is a Lennox True Edge Metal Master. And with what I was saying with the fixed stroke, this manually turns over the machine. So it's just I rotate this, you can see that this is a dual stroke. So we have a deep stroke and a shallow stroke. And how that works is coming off of our electric motor, there's an eccentric and that drives a wedge that pushes down on our upper ram here. So it's always going to be a fixed stroke. This handle here will change the amount of stroke. So it swings the electric motor around to drive the eccentric farther in so we can get a much more aggressive stroke. Or we can pull it the other way and we can get a much finer stroke. So we're changing how much the upper ram moves throughout its rotation off of the electric motor. So I leave it set here where I've drawn a mark that's 90% of the use. Doing bead profiles, doing louver work, all of that is gonna be done here in the 90%. So with speaking of that, now that you understand kind of what the machine is and kind of how it works, again, we're not going deep into depth because we could spend a month talking about reciprocating machines. I'm just trying to get you enough information to where you have a basic understanding of the difference between a reciprocating machine and a different style machine, how it operates, and now we're going to get into what you can do with it and what kind of tooling to use. So with these being fixed stroke, it's always going to move vertical. You can do bead profile work, you can do edge turning, you can do wire edging, you can do hem work, 90-degree edge sets. There's all kinds of tooling you can make for these that's not super complicated and do a bunch of really cool things. You can also use thumbnail shrinking dies on these, which I don't like to shrink on a reciprocating machine. I feel that it doesn't do nearly as good of a job as a power hammer, but I also have a power hammer to do that. So if all I had was a reciprocating machine, I would do a lot more shrinking with it. So let's cover different types of bead profiles and how we make those. And we'll set this up and we'll do a couple different things to show you how it works. And again, this is gonna be a 20-minute video, so we're not gonna get super into depth, but I just want you guys to be able to get out in your shop, be dangerous if you come across a reciprocating machine like a Lennox or a Pullmax. So let's talk a little bit about tooling. Before I get into showing you the actual tooling itself, I want to talk a little bit about the material I make the tooling out of. All of this tooling is going to be low production run, usually only used a couple times, so you don't need to get into using any kind of tool steel and then sending it out and having it heat treated and hardened. I just use standard 1018 mild steel tooling. I've got some tools that I use quite frequently that are 10 years old and they still work and look as good as they do the day that I made them. So don't get too wrapped up into, I got to make it out of tool steel, I got to send it out, be heat treated to last forever, because you really don't need the additional expense and time. So 1018, depending on which machine you get, it'll dictate what size. This Linux uses 3/4 by 3/4. If you're using a Pullmax or something made overseas, it's probably going to be in metric. So you just have to figure out which bar stock you can use that fits your machine. So let's talk about different types of tooling. So this is one that I got from Proline. This is a tipping tool. So this is the lower tool. This is our upper tool. This back gauge moves, so we can change where the offset is. And this is meant for turning edges up for like door jambs, roof inserts, deck lids, hoods, anything you need to turn an edge at a nice crisp angle. So this piece will come down and you're not gonna cut with it. You're gonna leave just under the material thickness, and it'll thin that and it'll turn the edge. We'll do a demo on this, so I think it'll make a little bit more sense once we do the demo. But you can do all kinds of bead profiles, and I label everything. So this one is a 1930 Model A sedan delivery belt line for the back door. There is the bottom tool, and here is the upper tool. And I just made these here on the Bridgeport to rough cut everything out, cleaned it up with a grinder and a hand file to make sure everything fit. So you don't even have to have fancy tools to make the tooling. You can use an angle grinder and files, and it's just going to take you a little bit more time. So that's one of the pieces of tooling. And I try to label everything to keep track of what it is, because if I've got dozens of sets of tooling and I don't have them labeled, I'm not going to know what they are. So always keep track of what your tooling is. Let's see if we can find another matched set here. So this one's a little bit more complicated. So this is a 33 Ford windshield opening. So that's our lower tool, and there's our upper. This is the windshield opening at the top by the roof of a 3334 coupe.
Did you make the shelving that you have?
Yep, so this I just designed in AutoCAD and burned it out on the plasma cutter, folded it up. Just real basic. Just something to where I can stay somewhat organized, because I do have lots of tooling and all kinds of different profiles.
And you basically keep every tool you make too.
Yeah, so this one's a 1940 Cadillac LaSalle door top. So I made an integrated back gauge. That way the sheet metal comes back and makes contact and lines everything up. Yeah, I always keep everything because I don't know what I'm going to use again. I might never use it again, or I might end up using it all the time. Like this is one of the first pieces of tooling I ever made, and this is when I had a Nibbler Junior, so it's a little different, and I just cut the stems off and put new stems on to run it in the Linux. So this is a 3031 Model A belt line for like the door, and I probably made this tooling almost 15, 20 years ago. It's been around a while, but it still works just as good as it did the day I made it.
And you didn't get that heat treated or anything,
Nope,
right?
It's just standard 1018 mild steel. This is a good one to have, like say you're doing door skins or something that has a hem edge. Once you tip the edge, you can run it through a 90-degree tool set, and that crisps that up to a 90. So the lower tool is a little bit more open than a 90, and this is a little bit greater than a 90. So when it comes in that peak, you're not going to get any weird tooling marks, but it'll fold it to the 90. So once you get the tooling made, you're going to have to do some testing and make sure you don't get aggressive tooling marks and that kind of stuff. And that's kind of what you see is like we have this flat area in the middle. Like I said, this is 3/4 by 3/4 bar stock is what it starts at. So I come in and I radius the corners of our tooling, and that gives us a smooth transition for our lead in and our lead out. That way we don't get bite marks. So the more aggressive the tooling, the more aggressive your lead in and lead out needs to be. Let's see if I can find an aggressive tool. Yeah, so like this one, where it comes through that peak, it's a lot more relieved around there to get that to pass through. Versus, I'll use the sedan one again. You can see how shallow that is because this is not nearly as aggressive. So there's always going to be a little bit of fine tuning work to to get everything to work the way you want it to work. And like I said, you can do complicated ones, you can do super simple. Yeah, like this is just a standard partial round tool for doing like bead lines and floors. Or if you have a real shallow square joggled like you need to do, like so. This is just more of like a square bead. Nothing fancy, real simple.
And
but
do you polish them up like you would?
yes, I keep the tooling polished when I go to use it. So if I have a tool that, say, has dust on it or it's been sitting around for a while, I'll go ahead and clean that up and polish it. The nicer the finish on the tooling, the nicer the finish that's going to be transferred to your part. One other piece of tooling, I guess there's a couple, that I want to talk about before we get into demonstrating it. This is going to be one of the more handy tools you have, and this is just a bull nose 3/4 by 3/4. And what I use this for is we'll take a little bit of a field trip. We'll make what's called a sandwich die. So this is just cut into plywood. I put a piece of metal inside there so it gets a nice crisp edge. That comes in and it rides right in that groove, and it gives us this X pattern and allows us to cross over. So this is a really common technique with putting intricate profiles in panels using a reciprocating machine, is the sandwich style die. So here is what it looks like when it comes out. So not much cleanup, nice crisp corners. And the cool thing with it is you don't really have to have a female die. The female die is the wood form. So what I use is in the bottom of the machine, I'll put this plate, and all this plate does is help supports what we're doing with our sandwich dies. And I use them a lot. There's a few of them hanging around. But this is probably one of the most handy tools that you'll make. I mentioned doing thumbnail shrinking. So here's a set of thumbnail dies that Proline makes. Again, I don't use these a whole lot, but I do have them. And the last piece of tooling I want to talk about will be on this side of the machine. And you have to think outside the box. Not everything is going to be a bead in a floor or beadwork down the side of a car. Like this is some exhaust that I had to make for a 1935 Miller Indy car. So all of this was done on the Linux, other than just the rough forming to get the radius in. I had that pre-formed. They were 8-foot long sticks. So we had the tooling made that had all of these little bead profiles in it, and we did it as one unit. So everything's nice and uniform, top and bottom. And then I made secondary tooling to come in and do the lock forms on the side. But that tooling is a lot bigger than the ones I just had. So this is the bottom tool of doing that. You can see it has the corresponding radius in the corners for alignment, and then it has our individual beads. And I put a second post on there so we could crisp up the edges because it does deflect a little bit. So there's all kinds of tooling you can make, super versatile tool. I'm gonna set the machine up and we'll do a couple demos on different processes. We'll do a couple beads, maybe the Model A door. This is like a really nice round pocket that I've got in here, so we'll do that one. So yeah, let me get the machine set up and some test pieces, and we'll run some demos. Before we turn the machine on, I wanted to take note that this is a 3-phase machine, but we found these 110 single-phase VFDs that convert 110 into 3-phase, and these things are a lifesaver, especially for you guys that have home shops that don't have access to 3-phase and you don't want to run a big roto phase. These were about $100 on Amazon, and I run a lot of my machines on them, and they work really, really well. So I thought it would be helpful just to mention that don't be afraid of some of the bigger industrial machines, especially now with these 110 single-phase to 3-phase VFD converters. What we've got is, this is just a real simple tool I made on the plasma. So I cut essentially washers with plates, and I use these in floors. Like if I have to put a grommet or a rubber drain plug in a floor pan or an access panel, I'll use this to put that round pocket. So it's not just a plug in the top. It gives it a really nice recessed feel. So I've got some scrap pieces of aluminum we're going to use. So the tooling is set up. I like to add a little bit of panel lubricant just so it helps in the machine a little bit. And this panel lubricant is 50/50 ATF and mineral spirits. So I use this a lot. If you've seen our other videos, you've seen me use it, but it's the same panel lube we use when running the hammer and that kind of stuff. So how the machine is going to work when I turn it on, this adjusts the lower tool post up and down, and this is an adapter I make to where we can set the position. Usually on a Linux, it's either up or down. A Pullmax has a couple in-between stations, so you can bring it down gradually. So I made this little adapter that bolts on, and we cut off the knob and put on a pull pin. So now it has multiple positions, and it's not all or nothing. So just for what we're doing, I'm gonna set this all the way down because we're gonna adjust this up. So I'm gonna cross in front of the camera, and we're gonna turn the VFD on, and the machine is running. So for these, what I like to do is I'll bring our panel in, and I'll just slowly increase this. So right about here, we're about making contact. And then I'll give it a little bit of a turn. And then you can back the tooling down. Let me turn the VFD down. So now we can take it out, and we can wipe it off, and you can see how nice that little recessed pocket is. So now if you want to put a grommet or, like I said, a plug, like in a floor pan, this looks really nice and finished with a little bit of effort. I think it took me less than an hour to make this tool, and it gives that next level detail around your grommet or your floor plug. So let me change out the tooling, and we'll do another test on a different profile. So we're going to change the tooling out. So I'll raise that up, and we have a wrench and an Allen wrench. So we flip this little, on this machine only, we flip this over, and this is just a little eccentric to dial in the lower ram. We'll loosen our pinch bolts. And we can flip our lock over, make sure that's lowered out of the way, and then this whole ram will slide out of the way. And hopefully you guys heard that little boop. And then we have an Allen that comes in the side, and that drops our top out. So we're going to use the Model A belt line. So the top tool goes in.
So for this one, it does matter, or it doesn't matter which one's top and which one's bottom.
It does matter because you need the longer stem to go on the bottom to come down and get into the adjuster. In theory, it doesn't matter other than the stems are different lengths. And I have it written over here for when I make it. It just gives our upper stem is 1.5 inches and our lower stem is 3.5 inches. So when I go to cut new stems for new tooling, I don't have to measure it. I've got it written down so they're the same every time. So I leave this loose and then come back over here, Jamie. So we can take our eccentric and line it up, and then all I have to do to adjust that is rotate it, and it helps our fine tuning. So I'll rotate up our tool, and I'm using the light to look through it and get it centered, and that's where I want that to be. So then we can lock down our pinch bolts. Put our tools back. We can lay these over there unorganized style.
Did you tighten the top?
Yes, the top is tight because it's in there. So for this one, we're going to go ahead and use our back gauge. So I'm just going to lay this in there for now. And we will slide up our fence. Might have to lower that down just a touch. So we're lowering down the back gauge's height so I can slide that in. And for this, I'm not getting super carried away as long as we can use it. And I will adjust the height on this back gauge just to support the tube, or just to support the sheet metal. And you have to think, this lower tool is going to come up. So we want to make sure we leave plenty of area for that to make contact to where we're not going to run off the top of it when we need it on our last couple passes. So we'll snug that up. And I'll go back to the other side. And we'll lock our fence in place. So now that's set, we can lower the tool back out of the way. And I'm gonna put a little panel lubricant on this just to make it slide through the tooling a little bit easier. So one of the big things you have to take in mind when you're doing bead profiles like this is you don't want to do it all one shot, the full depth. You want to do it in increments. That's going to give it a much better finish. You're not going to get as many tooling marks. All of that stuff is just going to be a lot easier on wear and tear and yield you a better finished product. So we'll do it in stages. We'll get the machine running, we'll make a pass, we'll adjust the tool up a little bit, make a pass, and repeat that process till we're at the full depth that we want. Let me throw some gloves on and we will get to running this profile. So we'll get our gloves on. Just with the lubricant on the sheet metal, it's a good idea in case your hand slides so you're not slicing into your hand. So gloves are on. Turn the machine on, bring our RPM all the way up. We'll put that up against our back fence. Bring this up where it starts to do something. And you can see how little it's doing on its first pass. And you want your feed rate to be nice and slow and consistent. But from here, we're going to come up a half turn. And just a little bit at a time. You don't want to get carried away because that's how you get really aggressive tooling marks and distortion in your panel. So if it takes 6, 7, 8 passes or more, that's all right as long as your panel looks good. You can see it's starting to take its profile. This will be our last pass. And we'll wipe that off. And there we have our 3031 Model A beltline profile. So I was thinking about it while I was doing it, and I'm just going to end up throwing this away because I don't have a need for an aluminum test piece. But maybe what we'll do is in the comment section for all the test pieces we do in this video, if you guys want, comment that which one you want, I'll sign it and I'll mail it to you. So if you're interested in one of these test pieces, first come, first serve, and maybe we'll do this a few times. But if you want a signed test piece from the video, hit up that comment section and say you want it, and we'll go from there and make sure to get this sent out to you. So we'll go ahead and we'll take our Model A tooling back out the same way we did the little round recess. And then I figured to wrap this video up, we will just do a a demonstration on the tipping tool and starting the turn of a radiused edge, which is really nice. Like if you have to do wire edging on a fender or a hem on a fender, something that's not straight. If it's straight, you can just break it in a sheet metal break, but what if it's on a radius? Well, that's where the tipping tool really comes in handy. So I figured a demo on that would be nice. And if you guys want to see other demos on other tooling, just drop down in the comment section and let me know. We can do special videos on that. But, I mean, if I've got 40 sets of tooling, you guys don't want to sit here and watch 40 demos. At least not on the intro video to the Linux. So I can do as many videos as you'd like, but you got to let me know what you want to see. So I'm just going to bring this forward a little bit. And I'm not going to use the eccentric because I don't want to go get the tool to change his back gauge right now. So just for the demonstration, I'll just clamp it in here. And I don't know what this offset will be, maybe a 1/2 inch, give or take. But it'll get the point across and you guys can see how it works. So what I'm going to do is, usually I would take a scrap piece of metal off of the same sheet that the part came off of, and we'll set our depth with that. So I'll bring it up and we'll bring that around. And what I'm going to do is I'm going to turn the machine on, and right now I'm just trying to set the depth. We don't want it so deep that it's going to cut and smash a lot of this material out of the way. We want it just enough to slightly thin our sheet metal, and that thin spot will create a fold. So we'll turn the machine on. I'm just trying to get our depth set. And that's all we need. So hopefully you guys can see that real well. It's just slightly thinner, and it lets us fold up on that area. And I've locked our tool down. So the same thing, we're going to use this as our back gauge instead of using our straight fence, which we used on the Model A profile. And we're going to come in and we're going to follow that. And we'll do an initial run that's just going to put that thinned line on it. And then the next one will put up a little bit of pressure, and then the next pass and the next pass, and we'll just repeat that process. So this is where filing this edge gets super critical. If this edge is offset the exact amount you need this tipped edge to be, but it's cut crooked or it's wavy, that is going to transfer into your turned edge. So anytime you're using a guide edge in the Linux as a guide fence, you really need to be on point with your filing and make sure it's smooth and uniform, because that'll transfer through that and make your turned edges or your profile work look really sloppy. So let's get to turning this edge. We'll come in. Like I said, this pass is just thinning the line. So I'm making sure our edge is perpendicular to the back gauge, so we're not off like this. We're trying to do a nice sweep along this radius. And I'll do a little bit more upward pressure. And on our third pass, a little bit more upward pressure. And you should be able to see it start to fold up in the tooling. And on our fourth pass, we'll do a little bit more. Turn this down. We could keep going and get this close to a 90 and then get it finished off with our 90 edge set that I showed you a little bit earlier in this video. But just for now, demonstration purposes, you can see that edge is being pulled up and it's along a radius. So that's how I turn all the radiuses in the Linux using tipping tooling. As you do that, it's going to put a little bit of a reverse in this. So you'd have to come back with the kick shrinkers from one of our previous videos and fine tune that edge. So all the tools in the shop are going to work with one another to create finished parts. And that's a good tie-in to show how I use the kick shrinker for edge work when dialing things in that I did the major process on a different machine. So that is going to wrap up our intro to the Linux or intro to reciprocating style machines. There's still a lot more information about why is the machine set so high? Why do we have platforms in front of the machine? And we can address that either in the comment section or in later videos. But I don't want to drag this out too long. Again, I'm just trying to get you the basic information so you guys at home can be dangerous if you have one in your home shop and you're just not familiar with how it works, what it does, and the things you can do with it. So again, that's going to wrap up this video. Again, if you guys are interested in the 3 demo pieces, it's only going to be 1 per person, so drop down in the comment section if you want it. I'll autograph it and I'll mail it off to you, and you can do whatever you want with it. Make sure to check out our Patreon page, patreon.com/cornfieldcustoms. We're doing a Discord server where it's private question and answer chat, project display, kind of like an old forum. So if you're interested in that, head over to Patreon, check it out, and see all the great benefits there. If you haven't become a subscriber here on YouTube yet, please do that. It's greatly appreciated and helps us grow the channel. So again, thank you so much for tuning into this video. Check out some of our other great videos, and we will catch you on the next one.